Hi, welcome back to my channel. Let me show you how to complete the solution architecture design for one of the professional cloud architecture sample case studies, Mountkirk games. Google did provide a worksheet template for you to use to practice analyzing cases. The worksheet has the business evaluation and the technical evaluation two parts. The business evaluation has 3 columns with client, values, and immediate goals. The technical evaluation also has 3 columns with the existing environment, technical watch points, and the proposed solution. You can definitely use this template to prepare for your PCA exam, but I want to show you my solution-oriented way to propose the solution for this case study and how I draw the final architecture diagram. Are you ready? Pause the video if you need more time to read the case study. I will circle out the issues or requirements in the case study, then I will list the possible service solutions for each of them, and how I made the decision if there's more than one service for each item. End of the service evaluation, I will show you how to consolidate these services into one architecture diagram. Mountkirk Games makes online session-based multiplayer games for mobile platforms. In the executive statement, they also want to collect KPI and other metrics to do future analysis. Google did provide a mobile gaming analytics platform reference architecture. I will leverage this reference architecture with the enhancement on game backend platform and game analytics platform for this case study. I mentioned this reference architecture in BigQuery's cheat sheet. You can pause the video if you need to go through the reference architecture first. Now let's take a look at the compute choice for the mobile platforms. You can choose from a Firebase, GCE, GAE, and GKE as I mentioned in the Google Cloud Compute Decision Tree video. GCE, GAE, and GKE technically all can resolve the current issue on global scaling. However, the requirements didn't mention any refactoring code for the containerization, so the GKE is out of the choice. Also, the game servers will run hardened Linux distro, so the GAE with cloud endpoints will not meet the specific OS requirement. They also want to do some server-side integration. So based on all these requirements, the GCE, Google Cloud Compute Engine, with the managed instant groups will be the good choice. In the front end, you will using the HTTPS load balance as your global load balance for the traffic around the world. For the scan up and scan down, you will using the stack drive, now called cloud monitoring, with the custom metrics to scan up and down. So this is our choice for the compute engine. Now let's move to the second one is on the database. They are using a centralized MySQL database for reporting. This is not a very good idea to using the relational database for OLAP than for the reporting, because they need to run the intensive analytics through the ETL tool, and they also wanted to replace MySQL. Since there's no data processing pipeline such as Spark or other Hadoop ecosystem in the on-premise environment mentioned in the case study, so I will use the data flow instead of Dataproc as a data processing with the BigQuery for the OLAP and the data storage. Also, the BigQuery is okay to storing the 10 terabytes historical data, and the BigQuery also supports the queries access. You can check my video on the data flow versus the Dataproc for the comparison summary on the data processing pipeline. The next one is they mentioned they want to integrate with a managed NoSQL database. They wanted to store the game activity in a time series database. The fully managed Google Cloud service for time series database is Bigtable. You can query a big table from a BigQuery by creating a table in the BigQuery's dataset linked to the big table data source. Also, the data flow collector for the big table makes it possible to use the big table in a data flow pipeline. So the big table, BigQuery, and the data flow provide the possibility for data preparation or and data transformation for any future analysis. We can use Cloud SQL or data store to manage user profiles, but the best choice for manage game state is the data store. So instead of managing two different transactional database servers, I will use the data store to manage both the user profiles and the game state. The last requirement is we take a look on how we are gonna processing the incoming data directly from the game servers, also processing the files uploaded by the user's mobile devices. You can send the mobile event messages directly from the end user device running the mobile app to the PubSub ingestion layer, or to go through the game server. The main benefit of going through the game server is that the authentication and validation is handled by your application. PubSub also can buffer the live and later data. The processing files from a mobile device will upload to the cloud storage. We're gonna choose the multi-region standard storage bucket for holding the data. Data flow can do both real-time and bulk processing. Congratulations, the evaluation is done. Now let's draw the proposed solution architecture. I'm using Lucid chart to draw it. I find it very easy to use. You may use other tools, that's okay. Here the architecture diagrams looks like. You can see the mobile application with HTTPS load balancer for global traffic. Game servers use GCE with managed instance groups. Stack drive logging with custom metrics to scan up and down. Big table manages game activity. Data store manages user profiles and data state. By the way, you can move the game state into BigQuery if you need to do any future analytics on the game state. Use PubSub to ingest event messaging and buffer the live and any delay data. Use data flow for processing real-time streaming data and bulk upload files in the cloud storage. Use the BigQuery data warehouse for OLAP. This architecture also can be extended with BigQuery ML for deeper insight of usage patterns forecast. You can use the BigQuery data for BI reporting tools such as Data Studio, Looker, or Tableau for visual analytics and dashboarding. Thanks for watching, and as always, subscribe to my channel for more great cloud computing learning tips. See you next time.